Hello everyone and welcome to a metal framing webinar. Today we're going to explore how you can simplify light steel framing in Revit and CNC export. So today we're going to have a look at how you can create and manage light steel frame models in Revit efficiently. We're also going to explore how you can manage BIM data and create documentation fast and accurately. And then finally, I'm very excited to announce that we are going to introduce you to our latest solution, which is the CNC Exporter Cloud. More about this at the end of the presentation. So, a bit about myself. My name is Andrus, and I'm a BIM application engineer at aga-cad. I specialize in metal framing, ventilated facades, curtain walls, and CNC metal exporter solutions. I'm also a licensed architect in the UK and the EU, and I'm a certified Autodesk Revit professional. aga-cad was founded back in the early 90s, and our very first Revit add-on was developed over 15 years ago. We have users in over 130 countries around the world, and we are proud to say that we are part of the Arcans group. Therefore, clients can benefit from fast support through our global network of local partners. So, the aga-cad way. As you can see, we have a large range of solutions, and we develop them based on these three areas: 3D modeling and design, 2D drafting and documentation, and design data management and exchange. And therefore, for the majority of this presentation, we're going to look at metal framing, and at the end, we're also going to have a look at the CNC Exporter Cloud solution. So, the first step is that you need to prepare your Revit model for framing. Now, let's explore walls. When you frame your walls, especially if you are using prefabricated construction solutions, you need to make your walls and floors or roofs into panels. And then you would like to insert framing into them. However, when we use only native Revit tools, and when we do things manually, it will be a very time-consuming task because there is a lot of potential for errors and corrections. It's also a very slow process, especially in large projects, because it requires high accuracy. So now, in this video, let's compare these, the two workflows. In the first half of the video, we're going to look at how you can manually split this large wall into smaller panels, and then we're going to show you how you can simplify it with aga-cad. So, as you can see, we want to divide this wall into panels, and we can use grid lines or reference planes as our references for the split location. Then we will add some dimensions to these references so that we make sure that the split locations are in the exact places where we want them to be. Now, this requires a lot of manual effort. And once we have these references set, we can go to the Modify tab in Revit ribbon and then select the Split Element tool. Now, sometimes it's pretty straightforward, but sometimes it requires some attention to detail because it doesn't work always perfectly. When we try to tweak the ends of the walls, we might accidentally merge these walls, so we have to start everything over. So before drawing walls, just make sure you untick the box, allow join. Right now, we're going to do this manually for two of the walls after we split them, so that when we tweak their location, they do not merge. So you can see this workflow is very slow. It has a lot of room for potential mistakes, which can lead to errors in further modeling phases. So how can we solve all of the problems that we mentioned? Well, metal framing includes a solution called smart walls. And the smart walls has many features which can help you simplify the wall splitting into smaller panels. For example, you can set the split settings and make the maximum panel width 3.5 meters as an example, and then you can split your walls with some of the chosen features. So right now we're going to split them from start. As you can see, the start of the wall is on the left-hand side when facing those arrows. So we're going to split select from start, and as you can see, within less than a fraction of a second, our panels got split. And the results are accurate. The first panels on the left-hand side are 3.5 meters wide, and you also don't need to worry about the wall ends. If you accidentally tweak one of the ends, the walls do not merge. Now, let's have a look at other examples. Smart walls also include some other features where you can customize the gap configurations. So for instance, we pick a wall type. This time it's going to be exterior wall type, and you can set the gap distances for structural and non-structural walls. So we're going to set them at 10 millimeters. And when we go back to smart walls, you can choose other ways to split the wall. Let's say split by a number. And we want to split this large wall into 3 equal panels. And as you can see, the panels also received gaps at splits. In addition, you can split your walls horizontally, for example, by levels or by reference plates. In this case, we're going to select level 2 as our reference for splitting. And here we go. We have a horizontal split, and then we can make these panels even, we can subdivide these walls into smaller panels. So you can see how quickly we can control the wall splitting. So what we have learned: metal framing automates splitting walls into panels, and it saves time, eliminates errors, and you can also insert gaps between panels. Now, the second phase of the modeling, framing. Native Revit functions aren't efficient for light steel framing modeling, and it requires a lot of manual input. It's very difficult to make changes and updates, and especially in large-scale projects. So let's again have a look at our couple of examples. So we have a very small, very simple panel, and first we're going to use the native Revit tools to create framing. You will see how inefficient this workflow is. Now, there are a couple of ways to do it. Some Revit users use curtain walls to create framing, but in our case, we're going to use beam systems. And first of all, we have to pick a plane and then draw the boundary line around the wall. You can also change the beam direction. And as you can see, we have a stud in the middle. Of course, you can adjust the layout rules. For example, you can set to maximum spacing, and the maximum spacing is going to be 600 millimeters between studs, but we still don't have any top and bottom place. We don't have studs at ends. And to make things more challenging, what happens when a client says, well, I want an opening to be inserted in this wall? So how do we go around these changes? It's a very painful process. We have to unpin those studs, and again, we have to manually cut them. In a 3D view, it's a bit trickier. Maybe in the elevation view, it's more simple, but still, you get the point. The task is very time consuming, and if you want to make jam studs, aka king studs, you also have to put a lot of manual input, and we're just talking about one small window here. You can see we have to rotate those elements. Sometimes we have to then align them to the openings. Here we go. We have pretty much created the frame. But what if client says, well, I want some of my walls to be longer? Well, this is where matters get worse, especially if there are other adjustments made. We have to put a lot of manual work, and you can see how slow this process is. It's very inefficient. It's full of errors, and it's just a small panel. So how can we optimize our workflow? Well, with metal framing, you can select as many walls as you want, click frame wall, and all of the walls will be automatically framed. Now you can see that the software is reading the model, it's reading all of the walls inside this project, it's reading the shapes, the openings, their sizes, the heights, etc. And it's applying the frame according to the framing configurations, also known as the framing rules. And these are default rules, which means that you can customize your design. You can customize your framing configurations to suit your own design, and you will also receive a framing element library, which you can also customize with studs, plates, etc. And you will get support from us if you have any questions during the trial period, or if you're an advanced user, you can always reach out to us. So you can see it took us a very short time to beautifully frame all of these walls, and everything is accurate, everything was done fast. Now, what if we have changes in our walls? So what if we need to change the location of an opening or increase the size of a wall? Well, we simply update our frame after making those changes, and you'll see that in just a few seconds, everything was updated nicely. You can also make changes to the design of your frame. So let's say I don't want to have these blocking or nogging components. Therefore, we can modify our configurations, and we can disable the blocking and nogging from our frame. And as you can see, within just a few seconds, our frame was updated. And you can also notice that different openings receive different top cripples. So some get diagonal elements, some get vertical elements. You can customize these based on the type of an opening, door, window, and also by the size of an opening. And let's say I want for this opening to have 2 header plates and a couple of king studs on both sides. So again, it's very easy to make these changes. It's also very fast. Now, as you can see, this wall has a regular pattern. What about additional elements or elements that can interrupt a pattern? So let's say we want to add a stud in between these 2 vertical components. Well, we can simply go to add modify elements, and we can add an additional stud. As you can see, we've selected a reference stud. We can set a distance to half of a foot. We can also insert an array of elements, define array spacing, but now it's going to be just 1 stud. And you can also choose a type, a family type for that stud. So you can see that everything works fast and easy. And you can also add horizontal elements in a similar way. You just select a reference point. In this case, it's going to be those 2 studs, and you can rotate your elements, and you can also change the family types. And this time we're going to insert a couple of elements that will be spaced at 610 millimeters. It's about 2 feet, and it's also going to be offset from the bottom by 600 millimeters as well. So that's how fast you can modify your frame. Fast and easy. So what have we learned during this phase of the presentation? That metal framing vastly improves modeling efficiency. Because it accurately automates framing, the framing designs are also customizable. Therefore, you can save time and eliminate human error. Now, sheathing parts. Now we're talking about drywall layers, or gypsum boards, OSB boards. Usually users divide parts to get the sheathing on their walls. But splitting parts manually in Revit is a very frustrating process. It takes a lot of time to form sheathing, even for one panel side. It's also difficult to make modifications, and there's a lot of room for potential errors. So again, let's have a quick look at the two different workflows. Again, we have a simple panel, and first we're gonna use the manual methods of part splitting. So as you can see, we have to first of all create parts. Make sure to also use the part visibility. And then we can use intersecting references, which can be reference lines or grid lines. In this case, I'm just gonna add these splits using Sketch. So I'm adding these lines manually, and it's a very slow process. Again, I need to make sure that those distances are correct. And again, it's a very small panel. So we've done the changes, and we have these panels, but only for one side of the wall. Now, the good thing about parts is that you can insert openings, and those parts will update automatically. However, when you need to make changes to the wall shape, let's say make it longer, you will have to make those modifications manually one more time. So I have to edit the division and edit those lines. So maybe I can just duplicate those lines, and we have an additional split. But then again, it's only for one side of the wall panel. Now, let's explore how you can improve your workflow efficiency using metal framing. So as you can see, you can keep the part visibility on, and you don't need to use create parts. We don't need to do it manually. We just simply need to create framing using frame wall command, and software automatically creates parts. And now you can split these parts, and with just one button click in less than a fraction of a second, size of this wall were split into panels. Now, what about a larger scale? Well, the principles are the same. You simply select our walls, we click split parts, and our software is again automatically reading the shapes of those walls, and everything was done fast. Now, what if, let's say, you need to make some changes to your design? For example, I don't want my panels to have that top bit remaining. I want my panels to be taller. So I can modify my configurations, and let's say increase the height of a panel by about 500 millimeters. And as you can see, the changes were applied quickly and accurately. It's also easy to modify and update part layouts, and therefore this improves your workflow efficiency. Now, the BIM data input. Inputting BIM data manually in Revit increases risks because it's a very time-consuming workflow. There's huge potential for errors, and data errors can lead to problems in prefabrication and construction. Imagine if you send an assembly with the elevations and schedules, and those schedules have errors in data. This can cost you a lot. So once again, let's have a look at the manual workflow. And let's start with a more simple object, walls. So as you probably already know, each wall instance has a mark parameter. And if you want to number your walls in Revit, you have to do it manually, which is a very inefficient process. You might make some mistakes. It's very easy to make an error. So let's undo all of this, and let's use a more efficient method using metal framing. So we're going to automate the values of mark instance parameter. So pay attention to the mark parameter value on the left hand side. When I click number walls, you will see that walls receive mark, and this value will be used for the number of your assembly. You can also use it for schedules, and you don't need to manually input anything. Now, what about framing elements? Well, you can use also FM sort mark parameter or mark instance parameter. As long as it's an instance text parameter, you can use different parameters for defining the numbers. Now, when you define numbers of framing elements, users usually pay attention to other parameters like cut length, because you want to categorize, or set the numbering arrangement, numbering rules according to different parameters. So when we do this manually, it's going to take us a lot of time, and we have horizontal and vertical elements. And you will see that using metal framing software, all of the FM sort mark parameters and also some other parameters will be automatically updated. You can obviously pick any other parameter that you want to automate. As you can see, studs, both the king studs and cripples and vertical studs, they receive a value, and horizontal elements as well. Therefore, it really improves your workflow. You can use these values for your schedules, and therefore you can ensure that your data will be accurate. Also, those numbering rules are customizable. You can, for example, number your elements by the cut length, or you can give them a unique number. It's up to you how you can customize. And we also have getting started videos on our aga-cad YouTube channel, which can be helpful, especially if you are trying out our software. Also, it's simple to update data after changes in the model. Let's say you reframe your walls, or you add new frames. You just simply click frame. You just simply click number walls or number elements, and all those changes will be updated. Now, assemblies and documentation. This is a very important stage, the documentation. And Revit has a feature called Create Assemblies. However, it involves a lot of manual tasks, and therefore creating assemblies and shop drawings manually is pretty time consuming, because you first of all have to manually select which elements will be included in your frame. You also have to manually dimension and tag all of those components. And there is a lot of room for error, and therefore poor documentation can lead to missed deadlines and even lost businesses. So let's have a look at how you can update how you can manage your assemblies. So first of all, we're going to look at the manual method. And as you can see, we have to be very careful which elements we select. Filtering out, well, we can filter out, but in this case, I think it's more convenient that we select elements manually, again, which is a very inefficient way of doing it. Unfortunately, there's no easy way when you only have native Revit tools. Then we can click Create Assembly, and you will see that on the left-hand side of the project, at the bottom of the project browser, you will get your assembly list. And there's another cool feature in Revit. You can automatically create views and apply view templates to them. Also, not only views, but also schedules. However, as you can see, those views do not include any dimensions. There are a lot of views in this assembly. And imagine that we have to spend so much time on manually dimensioning every single panel. If you have hundreds of these panels, it's going to take you ages. And it's also very easy to make an error, to select a wrong reference point. And it's a very slow method of creating assembly. So we're going to disassemble this assembly and let's explore the efficient way of creating your frame assemblies. So with just one click of a button, the software will automatically create views and schedules, and they will also appear at the bottom of the project browser. Right now you see that the sheets are empty, but that's okay because this is the very first assembly. Therefore, we're going to create the sheet layout using the views. And as you can see, views already have tags and dimensions, and you can customize how you want to dimension. You can choose your dimension types. So now we're gonna just finish our layout. We can add remaining views into the sheet and also some schedules. You can also create as many schedules as you want. One can be for your framing elements, the other can be a material takeoff, and so on. Make sure that the views are in the position where you want them to be. We can also create not just one sheet, you can create multiple sheets. And in this case, one sheet is for framing and the other sheet is for our parts. As you can see, they also already have numbering values, dimensions, and schedules. So now, once we have layout of this assembly, we can go to the drawing configurations and we can use these sheets as our layout templates, so that when we create other assemblies in the project, the sheet layout will be exactly the same. So let's pick this wall in the middle with a window, and let's click Create Assembly. And within a few seconds, our software will generate views and schedules one more time. But in this case, all of those views will be automatically placed onto sheets. As you can see, the sheets are full and we don't need to do anything manually. So imagine how much time you can save on your documentation process. Also, the documentation becomes accurate. You eliminate manual dimensioning and tagging tasks. There is no need to drag and drop views for every assembly, just for the very first one. And once you set the layout template, you can speed up your assembly creation process. Therefore, this will help you keep up with the deadlines and save time. And now, a very special moment. We are very happy to introduce you to our CNC Exporter Cloud. Right now, it's a beta version, but CNC Exporter Cloud will become a more flexible platform for exporting framing data. You can upload a Revit model, which can be accessed by multiple project stakeholders. It's easy to customize export settings and CNC command names, and you can track the export process. So let's have a look at the CNC Exporter Cloud. So you can choose which model you want to load into the platform. Once it has been loaded, you can see we are using the same model as we did in Revit just a few moments ago. We can also select the walls from the list and walls that we want to export. So we're going to export the same wall that we exported in the Revit model. Now, in the export settings, you can choose which CNC machine configuration you want to use. if you don't see the CNC machine that you're using, we can customize it for you. Therefore, the exporter can be used very flexibly. You can also define other settings. So, for example, you can choose which CNC command you want to modify. So, for example, lip cut. And instead of lip_cut, we are just going to use lip. Now, once you have made all of the changes to the settings, we can save these. And we can continue exporting our chosen wall. So once the file has been exported, you can find it on your computer, and you can then use it to upload it to your CNC machine, and your CNC machine will be able to read it and then produce framing elements. You can also track which walls have been exported, and you can always download the CNC export file. Plus, you can create different workspaces and upload different projects, multiple projects into each workspace. And you can also control who is going to access the workspace. You can see the list of people who already have access. So a CNC Exporter Cloud is a more flexible option because users don't need to have Revit installed to access the model and export CNC files. Also, it can be used by multiple users in the project team, and it's easy to manage CNC command settings and track the export process. So visit our website, cnc.aga-cad.com, and try out the CNC Exporter Cloud today. And make sure to use the metal framed walls or floors, and also make sure that your walls are numbered as well as your framing elements. We have plenty of getting started videos on our YouTube channel. And also try our metal framing for free. You can visit our website and download the aga-cad doc. By the way, the CNC Metal Exporter is a beta version, so therefore we are looking forward to receiving your feedback. So if you would like to automate your workflows quickly, book a personal meeting with us, visit our website, aga-cad.com. So thank you very much for your attention, and until the next time.